Chapter 1, The Dawn of a New Computing Era. What if I told you that a revolution is unfolding right now, a breakthrough so powerful it could change everything we know about technology? A discovery that defies logic, reshapes reality, and challenges the very limits of computing? Imagine a machine capable of solving problems no supercomputer could ever crack. A technology so advanced that it could break encryption, revolutionize medicine, and push artificial intelligence beyond imagination. Sounds like science fiction. Think again. Because the future of computing is no longer a dream, it's happening right now. This is quantum computing. And it's unlike anything you've ever seen before. Chapter 2, The Evolution of Computing. For decades, computers have shaped our world, evolving at an astonishing pace. From massive machines that filled entire rooms to microchips smaller than a fingernail, the digital revolution has transformed every aspect of our lives. In 1965, Intel co-founder Gordon Moore made a bold prediction: computing power would double every 2 years. For decades, this was true. Smaller transistors meant faster processors, leading to the rapid growth of artificial intelligence, smartphones, and the internet itself. But now, we're reaching a limit. Transistors are already microscopic, only a few atoms wide. Soon, shrinking them further will be physically impossible. Computing, as we know it, is slowing down. And this is where quantum computing enters the stage. Instead of relying on the old rules of classical computing, quantum machines harness the strange and mysterious laws of physics itself. A new era is beginning, one that doesn't just improve computing but redefines it entirely. But what makes quantum computers so different? To understand that, we need to dive into the bizarre world of quantum mechanics. Chapter 3, What makes quantum computers different? Classical computers process information using bits, tiny electrical signals that exist as either 0 or 1. Every app, every website, every digital system you use is built on this simple binary foundation. But quantum computers don't play by the same rules. Instead of bits, they use qubits. Unlike classical bits, qubits can exist as 0, 1, or both at the same time. This strange phenomenon is called superposition, and it's what gives quantum computers their incredible power. Imagine trying to navigate a massive maze. A classical computer would check each path one by one, step by step. But a quantum computer? It explores all paths simultaneously. This ability to process multiple possibilities at once makes quantum computing exponentially faster for certain types of problems. But there's something even stranger, something Einstein himself called spooky. Quantum entanglement. When two qubits become entangled, their states are linked, no matter how far apart they are. Change one, and the other instantly responds, even if they're on opposite sides of the universe. This bizarre property allows quantum computers to perform complex calculations in ways that no classical machine ever could. But how does this translate to the real world? How will quantum computing affect the things we rely on every day? The answer might surprise you. Chapter 4, The Power of Entanglement. Quantum entanglement is one of the strangest phenomena in physics, so strange that even Albert Einstein struggled to believe it. He called it spooky action at a distance. Here's how it works: when two qubits become entangled, they share an invisible connection. No matter how far apart they are, even if one is on Earth and the other is light years away, the moment you change the state of one, the other instantly changes too. This isn't just theory. Scientists have already tested entanglement in labs, even teleporting quantum information between particles miles apart. But why does this matter for computing? Because entanglement allows qubits to work together in a way that classical bits never could. Instead of handling calculations one by one, quantum computers can solve incredibly complex problems in parallel, exponentially increasing their processing power. With entanglement, quantum computers could simulate chemical reactions, design new materials, and even create unbreakable encryption. It's not just faster computing, it's an entirely new way of thinking about information. But the real question is, how will this change the world we live in? The answer lies in real-world applications, where quantum computing is already making an impact. Chapter 5, Real-World Applications. Quantum computing isn't just theoretical, it's already reshaping industries. Scientists, engineers, and corporations are racing to harness its power for real-world applications that could transform our daily lives. One of the most exciting fields: medicine. Drug discovery is a slow and expensive process, often taking years to develop new treatments. But with quantum computers simulating molecular interactions in ways classical computers never could, breakthroughs in cancer treatment, Alzheimer's, and even aging itself may happen much faster. Then there's finance. Today's markets rely on massive computational power for risk analysis and investment strategies. Quantum algorithms could optimize portfolios in seconds, unlocking new ways to predict economic trends and prevent financial crises. In artificial intelligence, quantum computing could supercharge deep learning, allowing AI to analyze data at unprecedented speeds. This could lead to smarter personal assistants, more advanced robotics, and AI models capable of understanding complex human emotions. And perhaps the most controversial application: cryptography. Modern encryption relies on problems that classical computers take thousands of years to solve. A powerful enough quantum computer could break them in seconds, threatening cybersecurity worldwide. Quantum computing holds limitless potential. But with great power comes great responsibility. Because while quantum computers could revolutionize security, they could also break it entirely. And that's where the risks begin. Chapter 6, The Threat of Quantum Computing. Quantum computing isn't just a technological breakthrough, it's also a potential threat. Right now, the internet is secured by encryption methods that would take classical computers millions of years to break. But a sufficiently advanced quantum computer could crack them in minutes. Banking systems, private communications, national security networks, everything that relies on encryption could become vulnerable. This is why governments and tech giants are racing to develop post-quantum cryptography, new encryption techniques strong enough to resist quantum attacks. Without them, the digital world as we know it could be at risk. But cybersecurity isn't the only concern. The sheer computational power of quantum machines could be used to manipulate global markets, disrupt financial systems, or even create AI so powerful that it becomes uncontrollable. Quantum computing has the potential to reshape society for the better, but in the wrong hands, it could become a powerful weapon. That's why the world's most powerful nations and biggest tech companies are in a race. A race to control the future. But who is leading this revolution? And how close are we to quantum supremacy? The battle has already begun. Chapter 7, The Race for Quantum Supremacy. The race for quantum supremacy isn't science fiction, it's happening right now. Governments, corporations, and research labs are competing to build the first fully functional quantum computer capable of outperforming classical machines in ways never seen before. The stakes: technological dominance. In 2019, Google shocked the world by claiming quantum supremacy. Their quantum processor, Sycamore, performed a calculation in 200 seconds that would take the most powerful supercomputer 10,000 years to complete. It was a historic milestone, but only the beginning. China, the US, and the European Union are investing billions in quantum research, each determined to be the first to unlock its full potential. Tech giants like IBM, Microsoft, and startups like D-Wave and Rigetti are also racing to develop commercial quantum systems. But true, large-scale quantum computing isn't here yet. The technology is still in its infancy, facing challenges like error rates, cooling systems, and stability. The question isn't if quantum computers will change the world, it's when. And when that day comes, the world will never be the same again. But how do these machines actually work? What does a quantum computer even look like? Let's step inside one. Chapter 8, Inside a Quantum Computer. A quantum computer isn't like the laptop or smartphone you use every day. It doesn't have a keyboard, a screen, or a familiar operating system. Instead, it looks more like a machine from a sci-fi movie, a towering, futuristic structure of gold-plated wires, circuits, and vacuum-sealed chambers. At the heart of a quantum computer is its cryogenic cooling system. Unlike classical computers, which operate at room temperature, quantum processors must be cooled to near absolute zero, colder than outer space. This extreme cold prevents vibrations and external interference from disrupting the delicate quantum states of qubits. Then there's the quantum chip itself, a fragile, almost alien-looking structure where qubits are manipulated using microwaves, lasers, and magnetic fields. Unlike classical processors made of silicon, quantum chips rely on superconducting materials that allow electrons to flow without resistance. But despite their complexity, today's quantum computers are still incredibly limited. They require massive infrastructure just to maintain stability, and their error rates are still too high for large-scale applications. Yet, with each breakthrough, scientists come closer to making them practical. And when that happens, quantum computing won't just improve technology, it will redefine what's possible. But where does this all lead? What does the future hold? The answer might surprise you. Chapter 9, The Future of Quantum Computing. The future of quantum computing is closer than you think. Scientists predict that within the next 10 to 20 years, quantum computers will surpass classical machines in ways we can't even imagine. From revolutionizing artificial intelligence to unlocking the secrets of the universe, the possibilities are endless. Imagine a world where diseases are cured before they even appear, where AI can predict and prevent global disasters, and where materials stronger than anything on Earth are engineered at the atomic level. Quantum computing could lead to breakthroughs in fusion energy, solving the world's energy crisis. It could crack the mysteries of dark matter and black holes, answering some of the biggest questions in physics. But with such power comes responsibility. Who will control this technology? Governments? Corporations? Or will it be open source, available to all? One thing is certain, quantum computing is not just an evolution, it's a revolution. And as we stand on the edge of this new era, one final question remains. How will quantum computing change your life? The answer? It's only a matter of time. Chapter 10, A New Era Begins. The quantum revolution is no longer a distant dream, it's already happening. Right now, the brightest minds on the planet are pushing the boundaries of what's possible. Every day, we move closer to a future where quantum computing transforms industries, redefines security, and unlocks the full potential of artificial intelligence. But the real question isn't if quantum computing will change the world. It's how fast. Some believe it will take decades before we see true quantum dominance. Others argue that the breakthrough could happen much sooner, within our lifetime. And when that moment arrives, humanity will enter a new era. A future where problems once thought impossible become solvable in an instant. A future where our understanding of reality itself is reshaped. But there's one thing you must remember. Quantum computing is more than just technology, it's a gateway to the unknown. The question is, are we ready? If you found this video fascinating, don't forget to like, comment, and subscribe. The future is unfolding before our eyes, will you be part of it?